So now let's get started. So there's 6 common steps when doing an ML project. So the first step we need to frame the problem, which means that we have to know what are we going to do. So it is a classification task or a regression task. Yep. And then we also have to get the data. So after getting the data, what do? We will explore the data. By explore, this means that we need to understand the data, understand which attribute in the data is helpful for predicting the target value we want on solving the problem that we are facing right now. Yep. And then we need to prepare the data for ML algorithms. So we know that ML algorithms need its data to be quite clean. So by clean means that it doesn't have anomalies or outlier or null value in the record. So we have to make sure the data is clean to fetch into an ML algorithm. And then we select a model and train it, and then evaluate its performance. Then after that, we will need to improve the model. There are several ways to improve it. So we'll go into it later. So today the session is going to be lecture session and then followed by the hands-on session. So we are going to solve a data set called Titanic. So it is actually from the real Titanic disaster that we want to get the trait of the passenger, and then we want to predict whether or not the passenger is going to survive through this Titanic disaster. Yep. So stay tuned for that. So now we are going to get a brief overview of what we're going to do later, so that you have a clear mind on what you are doing. Okay. So the first step, frame the problem. So that's the question you need to ask yourself. So is this a supervised learning task or unsupervised learning task? So supervised means that we have labeled data, means that our data input will have a respective output to it. So we want to find a function mapping that map X to Y. So we want to find a function mapping that map the input to the output. Okay, so for unsupervised learning, it will be, we just have the data, we just have the input. And then we don't have its corresponding output. So we need to find a pattern in the data to understand understand the data to get some insight from it. For kind of problem like if you have a big server room and you're not sure that which server is actually having problem right now, and then you have a lot of data about the temperature of the server, each of the computer, then you can do it via unsupervised learning. So you can see that there's some trait that the problematic computer will have through the data. So this is called unsupervised learning. So the problem that we are going to solve today is on supervised learning. So we actually have the passenger that mentioned that this person is going to be survive in this Titanic disaster. Yeah. And then after that, we need to know whether or not this problem is classification or regression. So classification, if you still can remember, classification is like we want to predict a discrete output. So like 1 or 0 or a cat or a dog. So this is called classification. And then regression. Regression is we want to predict a continuous value. By continuous, it means that we have to predict stock prices. Yeah. And then after that, we need to select a performance measure to use for this problem. So there are kind of performance measure for each of the problem. So regression, we have mean square error, or root mean square error is just a square root of mean square error, and then mean absolute error, and many more. So you need to select it based on your problem. Yep. And then classification, we have accuracy, and then precision, recall, F1 score, and etc. So there's many more. You need to select it based on your context. Yep. So moving on to the next slide, we want to get the data. So after writing a function that fetch the data to your environment, to your computer, or probably you can just download it, or whatever way that you can think of. After get the data, you should do this. So you need to split the data into training set and test set. Okay. why we have to split it into two subsets in the entire in the entire data set. Then we need to put the test set aside, and then we won't touch it ever until we train our model. So test set is the data that we'll use at last to get a sense of what our model will perform in a real problem, so in a real environment. So we need to get the test set out so that our model won't see the data in the test set before, and then that point we can really test the ability of the model. Yep. So training set with its literal meaning, so it's training, so it's used for training. Okay, so we want to work solely on the training set to prevent us from overfitting onto the entire data set. So we don't want our model to overfit the entire data set. And then we want to test it on the test set to see whether or not our model generalizes well to other data set that it haven't seen before. Yeah. So the ratio of the test set is typically below 40% based on the amount of data we have. So if right now we just have 1,000 rows of data, so we probably will need to split it to 70% and 30% because we need enough data to train the algorithm. We can't give too less data to the model. And for example, if right now I have 100 million rows of data, and then that's actually okay if we just take 0.1% of the whole data set as a test set. So this is based on the number of rows in the data set we have. Yep. So after that, explore the data. So by explore, it means that we need to understand our data through some sort of study. So the first thing that we can do is study each attribute and its characteristic. So if we get a data from a public site, then it will have some definition to each of the attribute it has. So we need to study it to understand it. And then because we want to know which feature are categorical and then which feature are numerical, so that later we need to convert this categorical feature to numerical one. So we need to convert it to number in order for the machine learning algorithm to work. Yep. So from here is a snapshot from the data that we are going to use later. So here we can see that there's 891, so 891 row there, and at the edge and the cabin we just have less than it. So it means that this column contains null value. So later on we will need to handle it. Probably we will need to fill in with the maximum category that it has in the attribute, or we fill in with the mean value of the numerical value. Yeah, so it depends on whether or not the model is going to be perform well with the way we fit it. So yeah, and then from here, survive. So survive is a target variable that we want to predict. So survive. And then P class ordinal means that ordinal is like 1, 2, 3, and 4. So it's like a rating from 1 to 5. And then the rating is actually having meaning. So each of the value having each of the meaning that from bad to good. So this is ordinal. And then discrete is like just discrete value, discrete category. Yep. So understand our data by studying each attribute. Okay, next thing is we can visualize the data to understand it. So we can plot each of the attribute to the target value that we want to predict. So now this one is the plot that we get from here. So get from the data just now. Okay, so from here we can see that this one P class is actually meaning the socio-economic status, and 1 means upper class, and then 3 means lower class. So we can see that the upper class will have a higher survival rate. So 1 means survive than the lower class. We also can see that the 0 is death, so not survive. So the P class 1 will have the value of 0 is increasing from 1 to 3. Yeah, so from this visualization, we can infer that upper class people has highest surviving rate. So the purpose of doing this is we want to understand, is this P class useful for our ML algorithm to learn? So if not, we are going to drop it later. So from this, we probably can say that this P class is actually pretty useful because it has a trend there. Okay, so moving on, we can understand our data by determining the correlation of each numerical feature to the target. So correlation is actually called Pearson R. So it's Pearson correlation coefficient. It ranges from -1 to 1. And then when it near to 1, there's a strong positive correlation. So it means that if X increase, Y will increase. So if near to -1 means that it has strong negative correlation. Same meaning. So the higher X, the lower Y. And then near to 0 means that no linear correlation. So we can use this Pearson R to understand our data better. So this is like, from the figure here, we can see that the positive correlation is like a line with its gradient positive. So with its positive gradient. Then if the data is like this, we can't really know anything about it because this Pearson R can't know about the more complex correlation. So it just can measure the linear correlation. And then negative, it will go down. Yeah, so this is the cons of it. Okay, so let's move on. So this one is the example output we get from the data. So we see that the P class is actually having a negative correlation to the survive. So it means that the lower the number of P class, the higher the survive rate is. So let's see if this is the case. Yeah, so it's the case. So when it is 1, means that it is upper class, and then it's a higher survival rate compared to the other. Yep. Okay, so we can use this when we want to explore our data. Yep. So let's move on. This one is from a survey that say that data scientists spend 60% of their time on cleaning and organizing data. So most of our time will spend on this, and then just a little bit of it, 9% of it is mining data for pattern. So you can see that data cleaning, data exploration is pretty important in the data scientist job. So yeah, so we can't deny this. We have to learn this properly. Okay, and then data preparation, which is the step that prepare the data for the ML algorithms. So data cleaning, we might have incomplete or anomaly that results from human error. So see this figure. So assume that it is a column that called university name, and then is in a data set. If you get it through a survey form, people probably just feel, okay, Uni Malaya, UM, or all kind of way they can think of. So for this even have a spelling error. So how you should handle this? So through cleaning data, you should only make it to just a true value. You can change it to University of Malaya. So every of this need to change to University of Malaya. Yeah, you have to clean it properly for this. And then we need to fix or remove the outlier. So if the data is too far apart from the normal data that we have at the center, we need to remove it because it might probably affect the performance of our ML algorithms. And then we need to fill in the missing value. So as I mentioned earlier in this slide, that we need to fill in this feature that contain null value. Okay, and then we need to decide whether or not we want to fill in with 0, mean, median, or if there's just one column, or if there's just one record, one row that has a null value, we probably can drop it. Okay, if there's too much, we won't want to drop it. So we need to find another way, which is to fill in with mean, median, or whatever that makes sense. Okay, yeah, so move on. Feature selection. So we need to select the feature that's most useful for our algorithm to learn. So if for this example, for example, this table we have here, the size in square feet and size in meter square is actually redundant, because we can actually just times this value to convert it directly into square meter using square feet. So we need to remove one of it, because the ML algorithm won't have any improvement if we put another redundant feature here. So we need to remove it. And then repeated column here is said to be linearly dependent with each other. So means that we can multiply some constant to it, and then we will get the size in meter square. So this kind of column, we need to remove it. Okay, and then also we need to drop the feature that provide no useful information to the task. So based on this, from here we probably can say that passenger ID is not very useful for our task because it's very near to 0. So we probably can drop it. So based on this passenger ID, so ID is just the ID. So it's probably not useful for this case. So we can decide which column that we want to drop based on the correlation coefficient. Okay. Next step, feature engineering. So some of the attributes might not make sense on their own. So combining the attribute could give more information to the model. So an analogy is here is saying that if we have time taken and distance travel, we can just combine it into one column, which is speed. So you need to think of this when you're solving a problem. And then actually this step is kind of optional, but it's good to do so. So if you let your model more optimized, can train more quickly, and then we'll get the target output more quickly. Yeah. So moving on to handling categorical attributes. So just now we say that the ML algorithms prefer to work with numbers. So we need to convert the categorical value to numerical one. So there's two common methods here, which is Ordinal Encoding and Hot Encoding. So Ordinal Encoding is like converting it to an ordinal value, which is 0, 1, 2, 3, and so on, based on how many categories we have. So here, if it is never, we convert it to 0. If it is 1, we convert it to, if it is rarely, we convert to 1, and so on. I think you can make sense of it. Yep. And then there's another encoding method called Hot Encoding. So if there's 3 color here, we just duplicate it and make it into 3 feature, which each of the feature consists of its respective category. So it's called Hot Encoding because the value that's 1 here is like hot, and then 0 is like cold. So this is called Hot Encoding. Okay. So ordinal encoding will assume that two nearby value is more similar to 2 distant value. So 4 to 5 is going to be more similar than 4 to 1. So the ML algorithm will make some assumption there. So when training it, you need to avoid this as possible because this is not good for the ML algorithm. Okay, so this is not suitable for the categories that have equal existence, like what we said here. So the color, red, blue, and green. So actually all the color has their own is equally important, and it's not like having any ordinal value to it. So this is not suitable to use for this case. So when this case happens, we have to use one-hot encoding. This fixes the issue that one-hot, the ordinal encoding produce. But if there's a larger number of categories, and then one-hot encoding results in large number of input feature. So if I have 30 category here, then I will have extra 30 column, 30 feature to our algorithm. So this will slow down the training process, because the more feature we have, the more complex the problem will be, and the ML algorithm will need more time to converge to the optimal solution. Yep. And then the last step of data preparation is feature scaling. So we need to scale our data. There's a lot of ways to scale it. So if we not scale it, so it will look like this plot. So x1, x2 is two feature 1 and feature 2, and you can see that it range from feature 1 just range from 0 to 150, and then feature 2 range from 0 to 2500. So this will make our learning algorithm train longer, and the gradient descent process is going to be slower if we are using gradient descent based algorithm. So we need to scale it either by standardize it or scale it by min-max scale. So min-max scale is scale it to the range of 0 and 1, and then standardize is just scale it using the Gaussian distribution. Yep. So this is the way we scale with min-max, and then it is called normalization. So we will scale the output to the range of 0 and 1. And then standardization will scale the input to standard normally distributed data, which is the Gaussian with the normal distribution with mean of 0 and variance of 1, I guess, standard deviation of 1. Yep. So the standardized will don't have a bounding range, so the range of the standardization does not guaranteed to be here. So it is based on the data we have. So we can select either of it when doing our training process. Yep. So after finishing the data prep step, we move on to the train model step. So actually this is the only part that use ML algorithms. Yeah, so this is the only cool part that most people will think, because cleaning data is very messy to do so. Yeah, so this is the part that do with ML algorithms. So after the data is there, what we need to do is just like select a model and train on it. So actually training on a training set is not that difficult in this era, because we have a lot of library written already for us, and we just can call a function to fit on our data set. So it's actually pretty easy to do so. So that's why this is only a small portion of an end-to-end machine learning problem. Yeah. So there's a link here to the Scikit-Learn website, and then let me show it. So here is the Scikit-Learn documentation. We have a lot of algorithm here. We can select our algorithm here, and then there's a description to it for each of the algorithm. For example, I want to see support vector machine. I want to use it for classification. Yeah. We can view it from here. There's a lot of example code for us to refer. And then for regression is also here. So yeah, just check it out when you want to do it. Okay, so let me unshare my screen again. All right, so next step. After select the model and train it, we want to evaluate it. So use the performance measure that we select previously in slide the step 1. So this one. So if it's a classification task and then I select accuracy, so I'm going to use accuracy there. So I'll evaluate it, see whether or not our model performed well on the data set with the accuracy coming out. So yeah, so it's a metric to tell how well our model is performing on the training data, on predicting the target. So you can also use it to compare the performance of different models. So there's a lot of model out there. We can train a lot of model, like we can straightly train 10 model, and then we'll see which one perform the best, and we'll further improve it. Yeah, so this is actually the common step that people nowadays will take when doing a ML problem. Yeah. Next will be improving our model. So after training it, we need to improve it. How do we improve it? Yeah, the easiest step is try different model. So you can try different model. If it perform better, then it's very good. You can change to it if the condition allow to do so. Yeah. The next option is you can revisit previous data preparation step. So you can back to the data exploration and explore the data again. And also you can back to the preparation step, and maybe you drop the column drop the column this time. So you feel that you shouldn't drop the column here. So you undrop the column, you get a column again, and try to train the model again and see whether or not it performs better. So this is the way to improve our model. And then hyperparameter tuning. So this is another one that we are going to look into. So actually, we can say that actually this step 4 to 5 is going to like an iteration. We need to repeat it until our model is becoming better. So there's no upper limit to it. So we need to keep iterating to get to our best model. Yeah. So as the figures here show, we optimize our feature set, which is that we select the best feature and we combine the most meaningful feature into one. And then model hyperparameter and architecture search. So we search for the hyperparameter used in the model, and then we come up with an improved model. So it's like a step that keep iterating. So yeah. So we are going to dive more deep into hyperparameter tuning. So hyperparameter tuning, what does it mean by hyperparameter? So here's a snapshot from the Scikit-Learn documentation. So this is on support vector machine, which is a model that are able to predict, are able to fit the data without affecting too much by outlier. So if I have two cluster of data here, cluster 1, cluster 2, and then we feed the SVM algorithm to it, and then it will have a model that's centered around this data. So it won't come out with it won't be fit too much to the left or right. So it will just balance just right. So this is the algorithm to it. So there's a lot of hyperparameter here. So all of this to the class that we input to the class is called hyperparameter. So this all. So later we will need to search for the best set of hyperparameter. And then one thing to note that is this verbose is actually not a hyperparameter, because this one is just like when we train the algorithm, it will output the cost of it per iteration. So verbose is like how verbose we want the output going to be. So this won't affect the performance, the performance of the algorithm, and this is not a thing that we want to tune. So usually the thing that we want to tune is just the first few one, and then yeah, that's pretty much it. And then so we want to search for the best set of hyperparameter for the models on the data set that we have. And then the two common ways will be grid search and randomized search. So what does it mean? So grid search is, for example, if I have two hyperparameter here, and then I have three different value for hyperparameter 1, and then three different value also for hyperparameter 2. And then we will just put it like a grid, and then we'll train nine model here. Okay, we'll train 9 model here, and then we'll see which model perform the best, and we'll pick the one. We'll pick the set of hyperparameter that used by the model there. And then randomized search is like we will specify a random range, a range of the hyperparameter, and then we'll just randomly select the value of it in the range. Okay, same goes to the another axis, so hyperparameter 2. So if I have many more hyperparameter until 3, so you can imagine like this, just like a 3D plot that have a cube. So each of the dot we need to train a model on it. Yeah. So how do we evaluate each of the dots? So each set of hyperparameter, how do we evaluate it to compare with other set of hyperparameter? So it's through a method called k-fold cross-validation. So we give a number of folds that we want to split on the training set. For example, in the figure here, we split it into 10 folds. So our training set, if we have 1,000 row, then we'll split it to 100 row per fold. Yep. And then we'll just so the k minus 1 fold, the 9 fold will be the fold used for training, and the 1 fold left will be used for testing. So we'll do it for k fold, the k number of iteration based on the k value that we provide. So we provide 10 here, so we will do it for 10 times. So after we split the data into 10 fold, then we repeat it 10 times and train it on the algorithm by using the same hyperparameter that we want to test. And then finally we will average over it over k value. We will average over 10 value to see the final performance, final metric of the algorithm that it produced. Yeah. So basically, if I have nine dots here, so 9 set of hyperparameter, if I want to do 10-fold, I will need to train the algorithm 90 times. Okay, to see which of the 1-fold out of this 9 is the best. So why we are doing this? Because we want to avoid overfitting. So because we want to do this to select the best set of hyperparameter. So yeah, so this is the meaning of it. Okay, so I think that's all for the slides. So is there any question that you all want to ask? So if there's question, just drop in the chat box so that you guys will understand what does it really mean, and then you all will have a better session later. Yeah. So I think I'll wait for 1 minute. Okay, so I think within this 1 minute, I also want to remind that, so this is the 6th step that commonly used when doing an ML project. Okay, so actually, even if we are doing a deep learning, we are using deep learning algorithms. So it's like neural network. If we are doing that, the way is also the same, similar. We need to frame the problem understand the problem properly, and then we need to get the data and then split to the train and test set, and then explore data. And yeah, the step is still the same. We also need to optimize for the best set of hyperparameter in every ML project. Yeah. So if there's no more question, so there's one thing in the chat box which is on the attendance. Yeah. So you guys can fill in the attendance right now because just now there's some technical issue. So if there's no question, I think we will have a 5-minute break. Okay, so let's have a 5-minute break, and then later after that, we'll do the hands-on session, which is on solving the Titanic dataset. And then, yeah, we'll see you later. So we'll come back at 8:48. Okay. Alright, so welcome back. So it's 8:48 now, and I would like to remind you all that to sign in your attendance at the link sent by Joel and the chat box. Then right now I'll pass the session to Amos. Continue.
Okay, hello guys. So I'll be guiding you all about the Kaggle, the hands-on session. Okay, first of all, I would like you all to register an account at kaggle.com. Yeah, that will be sent into the chat. And then Jiaheng send the collab that we are going to use later. And what you need to do is you need to copy to your own drive and open the collab. I will share my screen. Okay, I'll give you all 5 minutes to register on Kaggle and then to be prepared. I assume you guys that have registered an account on Kaggle. Okay, so before that, this is the collab that we are going to using. So first of all, you need to connect first. There's a connect over here. Before that, you need to copy to your own drive and then you open from your Google Drive. Then you can connect over here and then it should look like this. So today we are going to learn about data visualization, data cleaning, and hyperparameter tuning. Okay, so the data set that we are going to use is Titanic and it's from Kaggle. So you can click over here, open in Kaggle. Okay. So this is the data set that we are going to use. Okay, so before we start, we need to understand what are the attributes. Okay, so you guys can read the description or whatsoever. So in short, so there's this thing that's called survival. This is the attribute that we need to predict. So if that he or she survived for the Titanic, then it's a yes, then it will be a 1, or else it will be 0, as it is a no. And then we have a P class, which is a ticket class. Over here, we can see that P class is a proxy for social economy status. And first is upper, second is middle, and third is lower. And then it will have 1, 2, 3 as upper class, lower class, middle class, and lower class. And then sex, we have male and female. And for age, is a fractional less than 1. The age is estimated in 0.5 form. And then we also have this SIP is the number of siblings brought together to the Titanic ship, siblings or spouse. And then there's a parent children. So these two are family related, but you can see siblings and spouse is like same tier level in a family tree, and then parents and children for Parch. And then we also have ticket number. We have fare. Fare is the fees. Then we have a cabin number, and we have embark. Embark is the place, the port that they embark into the ship. Okay, so here is like the description: siblings, spouse, and parent children. So there's 3 places that they embark from: is Cherbourg, Queenstown, and Southampton. Okay, so you need to what this Kaggle does is like they give you three CSV file. So this is the training data set that we are using. So this is they give you the passenger ID and other attributes like just now we mentioned above, and then this survive they have already given you. So we need to train from this data set in order to predict the test CSV over here. So the test CSV, the difference is they don't have the survive attribute. And then here gender submission, here is like the example submission file that you should submit. So there's passenger ID, then whether he or she survived or not, something like this. Okay, so before we start, I would like guys to download the CSV file. So you can download all over here, or you can download like over here, like the download. So here I will show you guys. Okay, so I download this. So the only files that we actually are using are train CSV and test CSV. Okay, I've downloaded the file, and then we will move on to our collab. Okay. So after we have downloaded the file, remember to connect your Google Colab over here. So we can upload our files over here. And click OK. And it's inside over here in our Colab. Okay. Of course, you can, if you you have the Kaggle API or whatsoever, you can also using command line to download the dataset from the Kaggle site itself. So the way that I showed is a manual way to import the dataset into the Google Colab. Okay, so we move on. So first of all, we need to import our libraries. And then here from previous session 2, we learned about pandas, NumPy, matplotlib. And then today we are also going to use Seaborn. So first of all, we import it. And then so currently we have train CSV and test CSV. So train CSV, we are going to name it as train data frame, df over here. And then train df.head is to look at the example of the data set. So we can see we are given passenger ID, whether he or she survived or not, the P class, the name, sex, age, SP, pouch, ticket, fare, cabin, and bar. And then we are also going to import our test CSV as test.dataframe. So over here, you can see the difference that we don't have the survive in our test CSV. And then there's this test equals test dataframe.copy. This one I will explain later. So we temporarily store it as test over here, a copy of what this original test CSV file is. And then remember last time in session 2, they taught you to use info in pandas. So we can see the size, the number of rows, and then some null value and the data type over here. So first, I will print the train dataset first and then test dataset. So we can see there are 891 rows in our training dataset, and we need to predict 418 rows in our test dataset. And then over here, I would like to stress this again, that our test dataset do not have the survive attribute. And this is the thing that we need to predict. So you can see survive, there's survive over here in the train data frame. And then while the test data frame don't have this survive. So this is the thing that we need to predict. Okay, to move on. So before we start, we need to do the data visualization. We need to look at, need to understand the data more clearly. Okay, so first of all, we look at P class. Okay, so the lower the number, the upper the class he or she is. So okay, so first of all, we print this value counts. Is that we need to check need to see each class how many people are there. So 3 is the lower class. There are 491 people, passengers, and then for the upper class we have 216, and then middle class we have 184. Okay, so this is the value counts. And then next, so here the first line, we are going to group all the P class together. So, and then we need to see their survival rate. So we group them together by P class, and then we need to take their mean of the survive attribute, and then we sort in descending survive order. So ascending equals false. And then we also, at the same time, we also plot the Seaborn, the cow plot histogram over here. We have our x-axis as a P class, and the y-axis is count, so it's a histogram, and then we use color to differentiate. So this is how it looks like. Okay, so we can see actually the P class over here. See if the he or she, the passenger, if he or she comes from they are upper class, they are more likely to going to survive. So we can see based on the P class equals 1, over here we can see that their survival rate is actually higher, and then middle class, and then it goes down by the class. So you can see P class equals 3, so this is the lower class. Many people died compared to the people who survived. So we can make a small assumption here. So our first assumption is if the passenger is have a higher class, upper class, so he or she has a higher survival rate. Yeah, so after we visualize, we can make an assumption over here. Okay, so to move on, so here's the sex. So we have male and female. There are 577 males and 314 females embarked to Titanic. And then this is the same thing as previously. So the only thing that we change is just we put the attribute sex. Then we realize that actually female has a higher survival rate than male. Yeah, you can see female actually have 74% of survival rate, while male has almost 19%. Yeah, so here's how we visualize it. So our second assumption that we can make over here is female has higher survival rate. Okay, next. So we have done P class and sex. How about we mix it together with age? Okay, so over here, we are using we just need to like visualize it only. Okay, so we can see over here, the x-axis is the age and the y-axis is the count. So this is the histogram plot. So we can see that actually over here, the lower class, and if it's a male, they did not survive. You can see over here there's a huge range between 20 to 48 over here, that people who died as a male in lower class. So we can visualize it something like this. And then we can clearly see that women actually has a higher survival rate. Yeah. Okay, to move on, so we also need to like visualize each attribute. So over here, remember just now the SP is siblings and spouse, the number of siblings and spouse. So we need to see, okay. So from this, we can see that actually people who embark without spouse or siblings are actually, we have like 608 people. Yeah, that's quite a lot. And then the rest are come with family. Okay, so we group them together. But we can actually, from this histogram, we actually, it's very hard to deduce like if someone's comes, like if he or she has one sibling, he should have a higher survival rate. Like it's very hard to deduce an assumption over here. So you just look at it. Yeah. And then to move on, so this part, the parent children. So first of all, we need to see the totals over here. So we can actually see that a lot of people, they embark on Titanic without parent or children. Yeah, 678 of them. And then we look at their survival rate. Also, like it's quite hard to know, to predict if someone comes with like X number of parent children, then he or she will survive or not. Yeah. Okay. So to move on, so we are going to visualize our attribute embark over here. So there are 3 places that they embark to the ship, and we can see people who embark using the Southampton. there's a lot of people, 644, and then we can visualize it. And then yeah, so this is the diagram. So we can see that actually people who embark from C has a higher survival rate than people who embark from Q and S. Maybe like you can think like maybe there are more things, like more rescue items from this embark C, this Shambok. This place, maybe people they have more survival skills or what. They have more survival items to save them. We can like mix this kind, we can think something like this. And then to move on, we have mixture P class, sex, and embark. And then we mix all of them together. And then we visualize in this way. Okay, so this line plot. So we can see that actually previously we deduced that female have a higher survival rate than male, and then so female have a higher survival rate, but this is not for embark this C port over here. You can see that actually male have a higher survival rate over here than female. Yeah, so yeah, this is the insights that we can get from data visualization. And then next we are going for to look at fair attribute. Okay, so from fair attribute, we can actually deduce that people who pay more, they have a higher survival rate from the Titanic. Yeah, so the assumption that we made is people who pay more, they actually have a higher survival rate. Okay, so to move on, so here are the assumptions that we made. People with higher class, they have a higher survival rate, and female has higher survival rate, and people who pay more, they are more likely to survive. And then we have a correlation over here. So before that, just now Jiaheng, he taught you guys like if the correlation is getting more positive, nearer to 1 means they are positive correlated, and then if close to -1, they are negatively correlated. So over here, the attributes that we can only see for the correlation are only the ones with numerical values. You can see over here, we don't have the name attribute because it's very hard to correlate for name over here because it's a categorical attribute. So over here, we will only have numericals. Okay, so what are we going to do next is we are going to clean the training set. Okay, so after we clean the training set, then we will do this correlation again. Okay, so first of all, our training set. So we need to drop the useless column. Yeah, so what do I mean by useless column? So so we can use this is null sum. So we look for the attributes with has a lot of null values. So over here, remember that in our training set, we have 891 rows. And then we can see that this attribute cabin, it has actually 687 null values. So that's a lot, and we need to drop this column because it's actually not very helpful in our data set. So, so over here we can print and see. So we can actually see like cabin is not that helpful. So we are going to drop it. So before dropping it, so we look at like the data set right now. So we're going to drop this column cabin over here. There's a lot of null values. And then besides, actually we found Actually, from here we can see actually the ticket also is like there's a lot of tickets that we also very hard to predict our survival rate based on the ticket, because the ticket are in like kind of randomized order. Okay, so we are also going to drop that, and then we're also going to drop the passenger ID. It's not that helpful over here. Yeah. So we are going to drop these 3 columns, and then we look back at our data set. Okay, we have dropped the passenger ID, ticket, and cabin. Yeah, so this is how it looks like right now. Okay, so next we are going to fill in the null values. So currently our data set, the 2 attributes that we are going to fill in the null values is age. We have 177 null values right now, and we are going to fill them. And then we have 2 null values for mbug. Okay, so to calculate to fill in the null values, so what I am using right now is the median. Okay, so we fill it this way. We fill the value, the age, by the gender. So over here, what I did is I have this median age man. So I look for the age that is not now, and then the sex is male, and then I take the median of them. Yeah, so we do this, the median age man, and then I have a small exercise for you all to do the median age for women, and then later we will put in this median into the null values. Okay, I will give you guys 2 minutes to do this. So what you need to do is you need to have this median age women. Yeah, I give you guys 2 minutes to do, and then you can put it in the chat box, like what you are going to put over here. Okay, 2 minutes has passed. I think there's no one. So I'll do it myself over here. So basically you can copy paste, and then you can change this to women. Yeah. Yeah, I saw Junmei answer. Yeah, that's correct. Yeah, so basically you can just take the man median and then you change this to female. And then, okay, let's move on. So here's our median age man and median age woman. So what are we going to do next is we are going to put it into our null values. So we need to fill in. So if he or she, if the passenger is a he, it's a male, then we need to fill in the 29 over here. If the passenger is a female, so we need to fill in this median 27 over here. So to fill in, we can use this LOC over here, locate. We locate this thing. Currently is the age is now, and then the sex is male. And then we need to fill in the age as median age man. Okay, so after we fill in, so we are going to we are still left with this embed 2 over here. There are two null values for embed. So what you can do like for embed, so previously we know that embed there are 3 places that where the passengers can embed. So what you can do, you can use mode. But over here, since this only 2 rows, so what we can do is we can actually drop them. Yeah, so this is another way of cleaning your data set. So what I'm going to do is I'm going to drop. So I'm going to drop an A, and then I'm going to print is there any null values left. Okay, so we drop these two rows already. So our shape, currently we have 889 rows. Okay, so this is the first part of cleaning. So what we have done is we drop the columns, the rows, and then we fill in the null values. Yeah. So next, so regarding the name over here, okay, let's see name. So we can see the name is in this form. I think this is maybe is the last name or what, I don't know. So maybe we find something important over here from name. So what I am going to do is I'm going to extract this Mr. over here. So like from this the passenger, we are going to look for this Mr., Mrs., Miss, then we are going to mix them together. So maybe people like doctor, maybe he or she has a higher survival rate lah. Like something like this. People have a higher class based on their name. Okay. So before that, we are going to see like what are the titles over here. There's a name called honorific. Yeah. So these are honorific. So we are going to use to split over here. First of all, we split by this comma over here. Then we take the second item. Then we're going to split the dot over here. Then we take the first. So technically, we can get this Mr. out of it. So I'm going to put all of them into a set, and then we are going to see what we have in this data set. What are the titles that we have? So we have cap, colon, doctor, and so on. So we are going to group this all together. So over here, I just assume that like this cap is an officer, major officer, like these are their ranks lah. Then Sir Royalty Lady, if he or she is lady, if she is a lady, then it's a royalty, and then and so on. So I'm going to use a dictionary over here. Yeah, okay. So what we are going to do next is we are going to create another column, another attribute called title. So the title is based on the name. So we're going to to get this, like extract this title, and then we are going to map on this dictionary. So let's say Mr. over here, we are going to map to Mr. Yeah, okay, so this is how we are going to use the map. We are going to use lambda over here. So first of all, we put it into the title, then we map it from the title. Yeah, so this is our new column, the title over here. Okay, so next we can print the values counts, means that the title, how many people have this title. Yeah, so 517 of them have Mr. Yeah, and so on. So after we have this title column over here, what we can do is we can drop this name. So we don't need this attribute already, since we got the title. So we are going to drop it. And then so what we are left is like this. Okay, so what we are going to do next is we are going to clean the categorical feature. So how do we determine which are categorical feature? Of course, like if you see over here, the head is very obvious that this sex and bug and title are the ones categorical. So in another way, what you can do is do something like this. So this train df describe, this describe is for numerical values, and then the ones that are not here are categorical. Or in another way, you can use .info, and then the data type is object. So sex is object, and bug and title. So the three attributes which are categorical are sex and bug and title. So we are going to work on them. So so first of all, like for sex, we are going to put female as 0 and male as 1. So what I did over here is a mapping over here. So here, this is a dictionary, so you are going to map. So if he or she, if the passenger is a he, then I put 1. If the passenger is a she, I will put 0. Yeah, and then these are sets. We are converted all of them to 1 and 0. And then next we are going to convert the embark station. Okay. So actually we don't have null value. So this is like this mapping is like for previously. If you do this mapping previously, you fill in the null values. What you can do is something like this. You have this to fill in the null value. So over here we fill S as 0, C as 1, and Q as 2. And then currently our embark all becomes 0, 1, 2. So so our third attribute that we are going to add it is title. So here is an exercise for you guys. So what we want to map is Mr. to we are going to map it as 0, Miss as 1, Mrs. as 2, Master as 3, Officer as 4, and Royalty as 5. Yeah, I give you guys 2 minutes to do. So basically we are going to map all this into 0, 1, 2, 3, 4, 5. So I give you guys 2 minutes.
Oh guys, I realized one thing is that if you run this cell for 2 times, then the thing, all the title will become not a number. So if you accidentally do so, you can select the cell you click and then click run time and then run before. So you rerun the entire notebook until this point. So you will get back the result. Yeah.
Yeah, correct. Yeah, Jiang is right. So it's good to like you don't run the thing twice. So the first time it runs and second time it runs, the things may change already. So yeah. Okay, so 2 minutes has passed. Anyone want to share their answer, or else I will type it out. Yeah, correct. Muhammad Zahiru. Yeah. Okay, I will just going to type. So we are going to map our title. So over here I can uncomment all this. Yeah, and then we can print what's our data set looks like right now. Okay. So we have done with our categorical features. So we are moving to numerical features. So basically what we are going to do is we are going to make all of the attributes between 0 and 1 is the best. So like for this age, we have a huge range. So we are going to fix it. And this fair, we are going to fix these two features. So this is the same thing. Okay, so we are going to settle this fair first. So for fair, so there are several ways that you can do it. Like one way, like we can, like the way that I'm going to do is over here is I'm going to split into three this fair into three range, fair range. I called it fair range. So this is a new attribute, fair range, and then I'm going to cut the fair as 3, and then I'm going to group them together. So when I do the cutting, they cut it nicely, the range. So and then I'm going to output their survival rate over here. So over here you see the fair range. Over here, so in the first range, the passenger has 37.5% of survival rate, and then over here people who paid more than 170 but less than 341, they have 64% of survival rate, and then people who pay a lot, they actually survive. Yeah, so this is what we can deduce over here. Okay, so we can count the values. So the majority is in this range, and then the rest are here. Of course, you can cut more like, so currently I cut into three range. You can cut to more range, but you need to avoid like there's a overfitting. It might occur overfitting. Okay, so after we have this range, so basically we are going to put all this fair into their respective range. So all of these, you can see all of these they all fall in this first range category. So we are going to make it as 0. So like for this first range, we are going to make it 0, then second range make it 1, and third range we make it 2. So 0, 1, 2. So over here we can use the LC over here to locate. This is the condition, and then what attribute that we are going to change. Yeah, so we are going to put them into this range, and then I'm going to drop this fair range. So over here I have already created a column which is called fair range. So over here I'm going to drop it after I comment this. Okay. So currently my range is 0, 1, 2. You can see over here all are zeros. Okay, so we have settled the fair. So right now we are going to settle the age. So what I'm going to do here is I'm going to if I'm not mistaken, it's called features standardization. Yeah, feature scaling standard.
This one will be normalization.
Yeah, this is normalization. So so I have a range over here. I'm going to divide the range. The range is max age and then minus mean age. That's the range. And then the current age minus the minimum age, divide by the range. Yeah, so and then I'm going to put the describe. So currently only yeah. So currently our age between 0 and 1 already. Yeah. So currently we have made all the columns have numerical values and they are very small. They are not like very large. And then just now I said that we are going to do the correlation again. So here we are going to do it again. So actually we can see over here sex. So remember that we put females as 0 and male as 1. So over here I have a negative correlation, means that so the sex actually it has a highly correlated with survival rate. And then over here we have title also kind of related after we have made all the mapping. So fair about fair we can see we have positive 0.1. Over here means that people who pay higher fare are most likely going to survive. Yeah. And then we can see the class, the lower the class, the higher the survival rate. Okay, so we have cleaned our training set. So currently we are going to do this data set for data cleaning for test set. So remember we have two sets. So over here we have a train set and test set. So after we clean all the training set, we are going to do the same thing on the test set. But the only difference that we are going to do on test set is we can't drop a single row. Why do I say so? Because if you drop a single row, then you cannot predict that row already. So never drop a row. Okay, so first of all, we are going to fill in the null value. Okay, we can see over here, we can fill in the age first. We have 86 null values. So over here, I did it in the same way, but from here, I'm just looking at the test set. I just look at the test set and I get their median for men and median for women. Yeah, so we can get 27, 27, and then we put it in, and we are going to change it like previously. Yeah. We are going to fill the null values. And then over here, you can see this fair over here. We have 1. So over here, what I did is I'm going to fill the fair with median. So fill NA with median. And then I'm going to check again. So the only only thing that we are left is this cabin. Okay, so previously in training dataset, we have dropped passenger ID, ticket, and cabin. So it's the same thing. We are going to drop these 3 columns as well. So after dropping, we are going to look at here. Okay, so basically the process is the same as the training set. So over here, the title. So we are going to do the same thing using the title dictionary that we declared previously. And then we're going to rename our title. Yeah, we have we have created this column title, and then we are going to drop this name attribute. Okay, so next I'm going to squeeze all together. So this for sex, embark, and title, we are going to do the mapping. Female is 0, 1, 0, and male is 1, and then for the embark, SCQ 0, 1, 2, and then title is the same thing now. So we are going to map all of them as the same as training set. Okay, so right now we found out that actually we have one null value in title. So what we can do, we can actually this interesting part. So for testing set, what we can do is like, let's say we currently have this one null value. So we can actually look at the entire row. Okay, so the title is now. So this passenger is a female, and then is a T class 1 is upper class, and then age over here. And then let's say, yeah, here is the fees. Let's say we just randomly, we put it as she as a Mrs. over here. So we are going to fill this NA with 2, value 2. Yeah, so what I just did is I just look at the specific row, and then I fill in the null value for the title. And then we are going to look what's the null value that we have. So currently we have cleaned all the, basically our dataset don't have null value right now. And then we are going to proceed with the numerical feature. So just now we have set 3 range for our fare, 0, 1, 2 in this 3 range. So we are going to do the same thing. There's a mistake over here. So this one should be, yeah. Okay, so in this range, yeah, okay. Okay, so the fare, we have done the fare, and then we do the age part. It's the same thing. And then we have cleaned our data set already. Okay, so after cleaning our data set, so what we are going to do next is model training. Okay, so remember what Jiaheng just now taught is that we are going to split our data. So we have this training set, we are going to, from this training set, we are going to split it like 30% for testing. So we train the 70%, and this 70%, the model learns from it, and then it never look at the 30%. Then we are going to predict the 30% of the test set over there. So over here, our X is the entire data set we also drop the survive over here. And then and then the Y is the survive attribute only. Yeah, basically X is the attributes without survive, and Y is the only one with survive. Yeah. And then we are going to use train test split from this library, model selection, and we are going to have 30% of them put into our test set. And then the training columns value, we're going to look at it. Yeah, so the training, currently we don't have the survive attribute already. Yeah, so currently we are going to use the Scikit-Learn. So here we have logistic regression and random forest classifier. So we are going to see how well they are going to perform. Okay, so basically it's like this. So you declare the logistic regression and what model, and then you feed your training data over here. Okay, I'll do the same for the random forest classifier. So I have these two, and then next, supposedly you should train and then you should predict straight away. So currently I'm doing the same thing. I'm using two different models over here. So why predict log over here? This one is for logistic regression. I use model logistic regression over here, LG, to predict the test set. Okay, and then we are going to compare using accuracy score, compare the y-test and the actual, so the 30% we have the actual score. So we are going to compare what we are predicting. Yeah, so we have 80.89%. And then random forest, we actually have a lower accuracy score for this. And then, so over here, let's say we are going to choose this logistic regression because it seems to have a higher accuracy score. So we are going to choose it, and then we are going to predict on our testing data set. So I put it as PRED over here, and then this is our predictions. 0101, the survivor, the survive attributes, and then we are going to put all of these into our CSV, and we put it as submission, and we are going to save as CSV. So remember that we need to submit in this format. So passenger ID and survive. So passenger ID, remember previously I put it over here. I have this test over here. So over here, why I put a test over here is I need to know each specific row, the passenger ID. So in the process of cleaning the dataset, I have already dropped the passenger ID. But in the submission, we need to have the passenger ID. So that's why I have a test over here. And then I'm going to use that as well. Okay, so this is test passenger ID, and I'm going to put all my prediction inside. And then I'm going to put this as submission 01.csv. Okay, after I run this, I have my submission over here. Okay. So actually, after you have this submission, you can download and you can submit in Titanic, but I will do this later. Okay, so next thing, so just now I just do a simple train test split, and then, but I didn't actually optimize it. So right now I'm going to use grid search. Like previously, Jiaheng taught you guys how to use grid search. So right now, I'm going to choose random forest classifier instead of logistic regression. So random forest classifier has several parameters over here. And then we are going to use grid search. So what are we doing right now is actually we are going to do hyperparameter tuning. So okay, let's set our grid. So this is a grid search. So first of all, we need to import first, and then we are going to set the grid. So over here, I set my max step is 5, 6, 7, 8. And then my n estimator is 460, 480, and 500. And then so over here, 4 times 3, we have 12 different points to predict. And then, okay, so first of all, we are going to declare our model. So I call it forest classifier. And then I put a random seed over here, 42. Random state is a seed. And then I'm going to use my grid search to search for all of these points, which one have the highest accuracy score. So over here, I'm using the scoring as accuracy and my CV as 10. CV is the K4. Just now Jiaheng taught you guys. And then I'm going to put verbose as 10 so we can see the progress while we run. Also, this percent type is a magic command so that you can know this particular cell runs how long. Yeah, so we are going to feed it and we are going to run. So basically we have 12 points. So the 12 points, each of them we are going to split into 10. Over here, CV is 10. So the K4, we have 10 folds. So for each fold, we are going to use the remaining 9 folds to train and then to predict on the current fold, something like this. So actually we have 10 folds for 12 points. So we are going to run this training part for 120 times. Yeah, you can just let it to run. And then we can see which one is the best, which one score the best. Okay, you also can read the description over here, like what is it doing. Okay, so for me, it roughly take 2 minutes. Maybe your computer is faster, then it can run faster for this part. Okay, so after running, so we are going to see which one is our best parameters. So we can see our max step is 5 and n estimator 460 is the best. Yeah. So what we are going to do now is we are going to train our XY inside, put our X and Y, and then we are going to predict our test set. So over here, we have our submission tool. Okay. So actually, you see over here, max step is 5 is the optimal and n estimated 460 is the optimal score. So over here actually means that actually here 5 is the best and 460 is the best. So what you should do next is you should grid search the ones lower values. Maybe max step is 3, 4, 5. And then an estimator, maybe you can put until 100, 200, 300, something. And then you search again. And then you find which one has the highest accuracy by doing this. Okay, so I will not go through that. You guys can do it as your own. So right now, firstly, I'm going to teach you guys about feature engineering. So we are going to make an assumption over here. People who embark with family have higher survival rate. Okay. So over here, what are we going to do is, just now we have these two attributes, which is SIP-SP and Patch. SIP-SP is the number of siblings or spouse, and Patch is number of parents and children. Yeah, so this is siblings and spouse, and then this is parent and children. These are family related. So what we can do is we are going to sum this together as family size. Okay, so people who embark with family, we make this assumption, people who goes with family have higher survival rate. Maybe you can think like people who goes there alone, maybe they make sacrifice. They see people like go to with family together, they help them first or what. Yeah, so this is a small assumption that we made. Okay, so first of all, we look at the current data set, how it looks like. So it looks like this SIP patch. So I'm going to create a attribute called family size over here. And then, so you're going to sum it with SIP, SP, and patch. And then, and he or she, himself or herself. Okay, so the family size can go until 11. And then we can see their survival rate for each one of them. So after we have family size, this is not actually what we want. So what we want is people who travels with family or people who travels without his or her family. So we have this attribute called alone. And then first of all, we declare as 0 first. And then those with family size equals to 1 means that he or she are traveling alone. And then we are going to put it as 1. So this is how it looks like people over here. This passenger travels by itself, he or herself, and this one as well. And then we are going to group them together. So over here, people who travel alone have 30% of survival rate, and people who travels with family actually have 50% of survival rate, from what we can see over here. Yeah. So after that, we have all of these. So what we are going to do next is, basically we don't need this SIP, SP, patch, and family size already. Yeah, so we can drop all of them together. And then we have narrowed down to lesser attributes we have. So we have this attribute is alone. So after we have done for the training set, you are going to do the same for testing set. So I'm going to run, and then I'm going to drop. Yeah, finally, we are going to train our model this time. Also, we are going to use a hyperparameter tuning over here. So our X is the attributes without the survive, and then Y is the attributes, is the survive, that column. Okay, so here we are going to do the same thing. We're going to do grid search over here. And then you're going to let it run now. Okay, I've successfully run it. Okay, so I'm going to see which one is the best parameters. Over here, 6 and 350. And then I'm going to train it. And then I'm going to predict. And then I put it into my submission. Yeah, so I have submission 3. So we can see over here, max step 6 and n estimator 350 is within the range that we have. So, okay, so max step we can't go further, like 5.5 cannot, right? So it's a discrete value. So n estimator, maybe we can predict like, can do another grid search like 330, 350, 370. Yeah, we can narrow down to find the more suitable one. Yeah, so over here we have done. So we have these 3 submission already. And then here are several improvements that you can do. So before I show you how to submit on Kaggle, so I will go through these improvements first. Before that, actually, I think I made a mistake over here for training set categorical, the fair part. So here's the data visualization. Yeah, so here's the fair range. Over here, I put it wrong over here. But shouldn't affect a lot as only like 3 people affected only. Yeah, and then you can rerun the entire code. Sorry for this mistake. Yeah, okay, so for the improvement, so what you can do over here, you can try it yourself. Use one hot encoder instead of Ordinal encoder for the embed attribute. So currently we are making the places that they embed the ports in Ordinal form. So they are actually are not related at all. So you can use one hot encoder. And then for data cleaning, you can use pipeline. So you can learn pipeline and then you can put in your data set, your training data set, and then you can put your test data set. So basically, like we have cleaned our data set. You need to clean it 2 times. So for training set and testing set. So you can put a pipeline, it's like make a function, something like this. Then you can put in your training set and then you put your testing set. They are doing the same thing. Yeah. And then while you are doing the pipeline, you can create a custom transformer by inheriting transformer mixin and base estimator. And then of course, you can further explore more other models to train. This Scikit-Learn stable. Right. This is the link that Jiaheng just now shared. And then of course, the actual way of doing hyperparameter tuning, it's not the actual way, it's more advisable to do randomized search first before grid search. So randomized search, you can find a region that has particularly high accuracy, and then you can do the grid search over there. Yeah, so that's how you should do. And then you can tune more features. Example, just now I just tuned max step and n estimator. So what you can tune more is the mean sample splits and more. And then feature engineering, just now I show you to find the is alone attribute. So you can think of more potential variables that you can aggregate together. And then here are several reading materials over here. Okay, so that's basically it. So right now, I'm going to download all these data sets and I'm going to submit. So over here to the Kaggle data set, so you can click submit prediction over here. And then over here, you see over here, you can upload your file. So I upload submission at 01. So you need to wait. Okay, upload. and then I make submission. Then you can see your score. Okay, I got 78%, something like this. And then, okay, I can do another submission. This is the ones that we do grid search on. See if actually increase or not. Oh, it actually decreased. We got 77.9. So this is not that good. And then we could do submission 3. This is the third submission that we use the family size is alone attribute, the feature engineering. And then we submit. So this is how you submit. And then we actually can get somehow a little bit higher the score. This is the first submission that we use logistic regression. So this is the one that we use grid search for random forest classifier, and then we do the feature engineering. Actually, it increased the score by a bit. Yeah. Okay. So yeah, that's how you submit submission on Kaggle competition. And then you can see your leaderboard over here. So so my highest submission is 79. And then over here, you can see a lot of people got 1.0, which actually means they have 100% in accuracy. So they are all like kind of, you can read like people who say why people get one is because they kind of cheated. Since this Titanic data set is kind of public, so they can actually get the actual data set and then they know he or she survived or not. So they basically they submit them like this lah. So it's actually doing this training model is quite hard to get 100% accuracy. So like these are, so in case if you are curious, so we can say that they are cheaters or what. Yeah, something like this. You can see like people really write article like what, like how these people get one. Yeah, so yeah, that's basically it for this workshop. Yeah. So so the only thing that you guys need to change over here is the fair range. Yeah, that's the mistake that I made. So for the fair range, so over here the last thing I put in another value of 500 something because I test another, like I test three range, then I test another range, and then I forgot to change. Yeah. So here you need to change the training set, and then for the test set you also need to change. Yeah, so this is the only thing that you guys need to change, and then you can self-explore more. I think that's all for it. Do you guys have any question that you guys want to ask? Okay. If no, I'll pass. For me, no, good explanation. Okay, thank you, Jinwei. Okay, I'll pass back to Jiaheng.
Yep. So later on, you guys can explore on the Kaggle website. So you all can also check out the others' notebook on doing this, how they get higher score than you. You guys can adapt to it. And then, yeah. So a gentle reminder: remember to fill in your attendance if you haven't already. And let me share my screen again. So. All right, so we need your help to fill in the feedback form. Yeah, we'll give you 3 minutes to do so until 10:13. So the Kaggle website is actually have a lot of challenge or competition on this kind of problem. And if you guys are free and want to explore more, really you can deep down into the platform. It's very wonderful platform. And also it provides quite a lot of course from introductory level to quite advanced level. So you guys can have a look at it if you are interested. All right, 2 minutes more. Now, before leaving, we'll need to take a group photo first.